And next, okay, I'm going to talk about operations in complex numbers and also properties in complex numbers. Okay, right, so let's start with operations in complex numbers. I think you know by now what is operation, alright, it is simply add, subtract, multiply and divide, alright. So how do you add complex numbers that are in Cartesian form? Easy, you got to just add accordingly. The real part with the real part, the imaginary with the imaginary part, and hence for sec plus w, it is simply 10 plus 3i. How then do you subtract? Again, it is the real part with the real part that you work with, imaginary part with the imaginary part that you work with. Hence, it is negative 4 plus I. Okay, so what about multiplication? You got to just expand brackets like how you have been expanding brackets, and hence, if you were to expand it accordingly, you should be getting 21 plus 3i plus 14i minus 2. Okay, so how did I get this minus 2? I should be getting 2i squared. You are correct. But since note that I is equals to square root negative 1, and that would make I squared equals to negative 1. Alright, so simplify accordingly. That is when you will get the answer. Okay, what then about division? Division, you will have to note this accordingly. It is 3 plus 2i divided by 7 plus I. How do we divide? You will have to first do rationalization. So what is rationalization? Rationalization simply means multiplying on top and bottom by the conjugate of the denominator. So for this case, denominator is 7 plus I. Hence, what is the conjugate? Again, like what we have done earlier in the previous video, conjugate of a complex form is simply changing the sign of the imaginary part. Hence, for this case, it is 7 minus I. Multiply on top and bottom accordingly, that is when you will get a simplified complex number. Okay, what then about polar form? Right, polar form, you are given sec to be 2c power 2 and you have got w to be 3c negative pi over 4. How do we add and how do we subtract? With polar form, it is a little tough. So I would suggest that if you are asked to add or subtract complex numbers that are in polar form, you first convert these polar complex numbers into Cartesian form, then work with addition and subtraction accordingly later on. Okay, so convert to Cartesian first. Right? And what about multiplication and division? You got to just multiply the moduli, and for this case, it is 2 times 3, which is 6, and you have to add the arguments, and for this case it is pi over 2 plus by negative pi over 4, which will then give you pi over 4. Alright, what about for division? Division, you got to just divide the moduli, hence it is 2 over 3, and you subtract the arguments. So for this case, it is pi over 2 minus negative pi over 4, which makes it 3 pi over 4. Okay, because pi 2 minus negative pi over 4 would give you pi over 2 plus pi over 4, which will then give you 3 pi over 4. Okay, so why do I put this here is because, okay, sometimes, okay, you might not want to work in such a way, okay? You might not want to, you might not be getting, you might not be getting an argument that is a positive, okay? It could be a negative. So what to note then? Okay, cis negative theta is equivalent to 1 over cis theta. Okay, you would got to just change the form accordingly and work on it accordingly, right? And what else do you need to note in this video? You need to know that cis 0 is equals to 1. You need to know that cis pi over 2 is equals to I. You need to know that cis pi is equals to cis negative pi, which is equivalent to negative 1. And one last one would be cis negative pi over 2 equals to negative I. Do I have to memorize this for? If you could, you may. If you couldn't, never mind. You can always draw it in a diagram, and this way it will actually help you to remember these 4 equations, right? So this positive x-axis has got the real part of sec. Okay, so I call this 1. And this has got an angle of pi over 2, and that is the imaginary part, and this is I. Okay, and this is the negative side of my real part, hence I call this negative 1, and that would simply give me negative I. Okay, horizontal is my real axis, vertical is my imaginary axis. Alright, so this is real and that is imaginary. This one has got an angle of 0, hence this is cis 0. That has got an angle of 90, which is pi over 2, therefore cis pi over 2. And this has got an angle of pi if you were to move in this direction, or it could be an angle of negative pi if you were to come in this direction. Hence, this is cis pi or cis negative pi to give negative 1, and one last one would be negative I equivalent to cis negative pi over 2. Why? Because it is 90-degree clockwise. Okay, right? And what then for properties of complex numbers? These properties will be useful when you work with application questions later. You will need to note that sec plus sec bar is equivalent to 2 times the real part of sec. You will need to note that sec minus sec bar is equivalent to 2 times imaginary part of sec times I, and that makes it imaginary. The moment I is around, that makes it imaginary. And what about for the last one? Sec times sec bar, it's equivalent to the real part of sec square plus by the imaginary part of sec square. Okay, so that is for this video.